What is electric current? So let's say we are observing any given wire in a circuit, right? And we're observing a particular cross section of it. And let's say we are observing also from time t to time, in this interval, time t to time t plus t delta t. Okay. So this is, we're observing it in this time interval, and we're measuring how much charge is flowing in one of the direction, let's say from left to right. And then we measure a total of delta q charge flowing from left to right. Let me use small q. Okay. All right. So then the average current in this time interval will be delta q divided by delta t. Note that it will also be a function of time, right? Because the average current, the delta q, may change depending on the starting point of the interval. Okay, so this is, in general, this average current in any given interval also will be changing from time to time. Okay, maybe changing from time to time. But that's basically how you define current. Is basically how much charge, the rate of flow of charge in any given direction. Okay, so and then we can also do, modify this definition to instantaneous current, right? So instantaneous current, the definition would be limit delta t tends to 0, delta q divided by delta t, okay, at time t. And so this will just be equal to I of t. Okay, so that will be the instantaneous current. And then according to the definition of the derivative, then that limit will be equal to the derivative of q of t. Okay, so then q of t is basically the, dq of t you can think of as the amount of charge which just which flowed across the cross section in delta t in dt time, right? That means then q of t, you can think of it as a total charge which has flowed to the other side at time t, right? So then if you again start from this relationship, I of t would be the derivative of q of t, right? Then you can think of I of t as the instantaneous rate of flow of charge, and you can think of q of t as the total amount of charge which has already flown in one in one of the direction. Okay. Now from here we can use fundamental theorem of calculus. Say fundamental theorem of calculus, and say, so this basically implies that integral I of t dt from, let's say, from t1 to t2 will be equal to q of t2 minus q of t1, right? This is what the fundamental theorem of calculus says. If one function is the derivative of another function, then let's say I of t is the derivative of q of t, then if you integrate I of t, that should be equal to q of t, and you apply limits this way, then the limits apply on q of t that way. Okay. And so this is basically the fundamental theorem of calculus. We just assume that we know this. Okay. And then if t1 is equal to 0 and t2 is just some other time t, then this will give us the total charge which has flown at any given time t, right? Starting from time 0, this will be equal to 0 to t I of t dt. So just so that we don't confuse between the t variable here and the dummy variable t, I'm just going to say it's 0 to t I of tau d tau, right? And then this will be q of t minus q of 0. And in many cases, we will have the initial condition that the charge which has flown, at time 0 is 0. So if we do have q of 0 is 0, then we'll just have q of t will be equal to 0 to t I of tau d tau. Okay, but at the core, the definition of current is pretty straightforward, right? It is a rate of flow of current. Then if that's the case, then we can also talk about units. because it is the rate of delta q over delta t, right? That's the units. Then that will give us a units coulomb per second. Okay, and this is what we call, or this is the equivalent to ampere. Okay, so that's basically the units for ampere is in terms of other units for amperes, coulomb per second.